complicated, but let me kind of explain what's happening. So I've got a 10 ohm resistor. Then this is why you draw diagrams, because otherwise, if you actually build it, you have like a jumble of wires. So I've got a battery. Boom, it's coming into a 10 ohm resistor. From there, it's coming into a 1,000 microfarad capacitor. And then it's going around here, and it's hooked up to that LED light. So this is just one circuit that's in series. Okay? So then over here, I've got a parallel circuit with another 10 ohm resistor and a green LED light. Okay? So I've got all of that in series, and then I've got this in parallel. So I'm not going to worry about this for now. Do not worry about the parallel part. Do not worry about the green light. It's not part of the system. Just ignore it. So what I want to do is focus on the blue light. So I'm going to close this switch. And you'll notice that the blue light initially got very bright, and then it went basically out. So let me explain why that happened. So the capacitor had to get charged up. So what happened, and this is why it went out, and this is when you deal with capacitors, they say the circuit was closed for a long time. So when I initially closed that current was flowing through that whole circuit, and that bulb got lit up. Once the capacitor got charged, then it's like you shut off the floodgates on the dam. And the capacitor says, I'm charged. Once it's charged, it's not letting any electricity flow through it. So that's the significance between saying, hey, this is immediately after you close the switch, meaning electricity is going to flow through it, and it flows through it until you fully charge the capacitor. Once you fully charge the capacitor, then it shuts it off. Now, I've charged the capacitor. I'm going to open up this switch, okay? So that's now dead. Now what I'm going to do is close this switch, which is hooked up to the capacitor. Then I'm going to take the energy that's stored in that capacitor and run it through that green light. So now when I close this, okay, it went very bright, and then it goes out. What happened?
The capacitor lost all its charge.
Exactly. So what happened was that once I had that charged and then I disconnected that, it's just like I had water stored behind the dam of this reservoir. So when I closed that switch, I let that water that was stored up here flow around. So this gave it a place for that water to go, and then it got lit up. So here's the difference. The blue light starts off bright, and then it goes dim. But it gets bright and goes dim because initially there's a whole bunch of current flowing through it, but once the capacitor gets charged, the capacitor stops the flow of electricity to the blue light. But then once it's charged, then it repeats that process. This gets bright and goes dim because then it's the opposite. Then I'm taking the energy that was stored, and then it's going to flow over here. Now, here's the next question. Okay? So, here's what I'm going to do. I'm going to close both switches. Okay? I'm going to close both switches. That's going to be closed. This is going to be closed. What's going to happen to the bulbs?
They're going to be like medium.
Medium?
Yeah.
Will they both light up? Why?
Eventually the blue.
Because the one that's like the capacitor is never going to be fully charged. Because
Why not?
The parallel is always going to be taking the energy that's put in it, so it's just going to be a constant loop.
Like a water cycle.
Okay. So, but why won't I charge up the capacitor? Why wouldn't that build up enough where it stops the flow to that blue light?
We're robbing the capacitor.
What's Mother Nature always going to do? Take the easy rate out, because Mother Nature is a lazy prima donna. So when that electricity gets to this point with the conjunction of the capacitor, she's going to go, what's going to be easier? Take that light, take that energy and put it to make the green light go up, or charge the capacitor. Mother Nature's going to go, screw that. I'm going to go over here. Okay? So let's see if that actually happens. All right. So we're going to go boom, boom. Okay? Both going.
Yeah.
Now, I'm going to open this switch.
That one's gonna dim
Why?
because the capacitor is gonna charge. It's gonna be fully charged, and then it won't flow through.
So if I open this, what are we going to force the electricity to do? Going to go through that capacitor, right? But then once it gets charged up, what's going to happen? Should go dim. So I do this. So this would go out immediately.
No.
Yes.
Yeah.
Yeah.
This is
Yes.
underconnected.
You're incompleting the circuit.
It's parallel. It's dead.
Oh, it's what I said.
Okay? So now, if I open this up and close this one, what should happen?
It lights up
Go
for
light up
some
and then go.
Light up and then go dim. Okay? So when you're dealing with that question on that lab, okay? So imagine that here's this capacitor up there on the top part of that diagram. So initially, and this is the whole key with capacitors in terms of the verbiage that they use. So when they say immediately after it's closed, that's like having this, I close that, immediately the electricity flows through. But then if it says, after a long period of time, that's the magic code for,
Dim.
or it's going to go out because the capacitor is charged, and then it won't allow the electricity to flow through. Okay? Got that visual?
Yep.
Okay, back we go.